Exercise a02 is not going to pose many problems in terms of implementation. It's going to be more of a lesson, a basic lesson in code reuse, pretty much. We are going to try to develop a stack, abstract data type, an integer stack, abstract data type, based on everything that we already developed so far for the integer linked list abstract data type in exercise A01. So we are going to have file stacky.h, that's the name of our stack abstract data type implementation, stacky.c, and test underscore stacky.c. In addition to those three files, we are going to have also in our current directory linky.h, linky.c, which we slightly modify so that it's now a combination of linky.c and linky underscore recursive.c. We put them all together because for the purpose of the second exercise, the idea was to reuse the code in linky, not to make the distinction between iterative and recursive. So we just opted for the recursive solution. And so we have all those files in our current directory for this exercise, and we're going to try to implement the stack abstract data type by reusing pretty much a tcell type and reusing all of the previously available function. We are just going to add our own push and pop function, which are typical of the stack abstract data type, and we're missing in our linked list implementation. So let's have a look at the files that are going to constitute this project. Okay, I already told you about linky.h being there, linky.c being the combination of linky.c and linky underscore recursive.c. And now we have here test underscore stacky.c, which is including stacky.h and which is pretty much looking really similar to our test.c for the linked list implementation. We have here a tcell star which we called my list. Should have called actually my stack. It would make a little bit more sense, but let's work with that for now. We're going to display the initial stack content, which is just one element containing the value 0. Then we are going to start pushing value 1, 2, and 3 in the stack. Then we are going to start popping values from the stack. And every time we pop a value from the stack, we not only remove it, but we turn the data field of that element, which we display on the next line. Okay, before to display the whole stack again to make sure we can visualize what was missing, what has been removed, etc. And we're going to do it 3 times. So this is the test stacky.c. If we have a look to the other files, we have here stacky.h. Stacky.h is going to pretty much add 2 functions to my abstract data type, which are going to allow us to use it as a stack. The first one is push, which push is a new value on the stack. The second one is pop, which actually not only remove the value that was last added from the stack, but also return its value. And the implementation of those functions are going to be in the file stacky.c, which we're going to look at right now. And this is where we're going to actually implement those 2 functions. So let's get started. Let's get started by the push function. Well, we need to decide something. Since our stack is going to be represented by actually a linked list, is the top of the stack at the end of the list or the top of the stack at the front of the list? Well, whichever you choose will work. You just have to stick to that convention once you establish it. So we're going to assume that the start of the stack is going to be the top. So pushing an element on the stack is really completely similar to doing a tcell add front on that linked list. And that shows you how we can reuse things that were already implemented here to provide new feature. For those who are going to use actually the stack features of our abstract data type, they are going to use push and pop exclusively to add element, and they are like not necessarily interested by knowing that we add the front or the back of the linked list. These are implementation detail, okay? But at least they are going to have a consistent interface with push and pop, and they don't worry about anything else. For the pop function, well, since we add to the front, popping means removing from the front. Okay, so we're going to have a little bit of work to do here, because unlike the previous function where we just call tcell_add_front and we let tcell_add_front detect error situation with the parameters. Here we're going to have to access the value of the first element of the linked list before to be able to return actually this value, right? So what are we going to do? Well, first we're going to make sure that our list is a valid pointer. If it's not, well, we have a problem here. We have a problem because when we call pop, we expect a value in return. If we cannot pop because, for example, one of the parameters is invalid, we cannot simply return 0 or return -1 because that's going to make it extremely difficult for the programmer to determine, the programmer using our pop function, to determine if when we return 0 we mean that there was a 0 on the stack and it's removed, it's popped, or that means that there was an error situation. So we could use exception handling. If we were in another language, we would probably start by that. Here we're going to try to keep this example simple. Only thing we are going to do is if there is an error in the stack manipulation, we try to pop from a stack that is non-existing or something like that, we are going to just display on the screen printf error can not pop from stack. Not really, many details here, but we're going to work with that. We're going to flush std out to make sure that this error message gets displayed, and then we are going to exit our program with an error code. For example, error code -1. And that means that we are going to need stdlib if it's not already included by stacky. So our first compilation will tell us that. Okay, so basic rudimentary error handling here. If list is not null, well, maybe my stack is empty. How do I detect this? Star list equal null. That means my stack is empty. Guess what? I'm going to use the same thing here. So this is really rudimentary, but let's try at least to give an error message here that is giving an indication of what went wrong. Cannot pop from stack. Let's call it null pointer. And this one will be cannot pop from stack. And it is empty. That should be enough for us to locate exactly where the error is coming from. I'm going to shorten a little this line here so we don't have this annoying little symbol appearing on the screen. There we go. So now we are going to, let me just re-indent this real quick, and now we are going to deal with the non-error situations, okay, which is, well, my pointer is valid, my stack has at least one element, so what do? I'm going to first save this value, int val equal star list error data. Once I saved this value, I'm going to deallocate the first element of the list, which I can do already with tcell del front. I'm going to pass list as parameter. And then, instead of returning 0 here, I can return 1. I'm going to save this. The file is being saved right now. Then we're going to go to the terminal and we're going to give a shot to this first version. So let's first clear the terminal from what was there before. We're going to compile our linky.c, stacky.c, which had a couple of functions, and test stacky.c. And then we're going to execute the test. Initial stack at 0, pushing 1 result in having 1 as a head. So the head of the linked list is actually the top of the stack. Pushing 2, pushing 3, popping. The first value we pop is 3, popping then is 2, popping is 1, and we are back with our initial list. So these are the two functions that we added to make pretty much an extended abstract data type which handles not only linked list feature but also stack features.